So, as you have already seen it, actually the quadratic equation should be a quadratic function with the general form f of x is equal to ax squared plus bx plus c. Actually, its graph is either concave downwards or either concave upwards. And the shape of the graph possesses the shape of the parabola. So the shape of the quadratic graph actually possesses the shape of the parabola. Hence, the graphs of the quadratic actual function are said to be the parabolic actual graphs because they possesses the shape of the parabola. Now, what determines the graph to concave upwards or the graph to concave downwards? Now, it is the value of a that determines whether the graph should have to concave upwards or downwards. In the sense that if the value of a is positive, it means the graph will have to concave upwards. If it is negative, it means the graph will have to concave downwards. So for instance, let's say we have this as the sample of the graph. Let's say this is the sample of the graph. There should be, this is the Cartesian plane, rather should be Cartesian plane. And we have to come up with, this is the y-axis and this is the x-axis. So now, whenever the value of a is positive, let's say the value of a is positive, it means the graph will have to concave upwards. Let's say this is the case. Let's say this is the case. Let's say this is the parabolic graph. It should be a quadratic graph. And that should be that. So which means here, the value of a is given as the positive. That's what it means there. So, the points in which the graph happens to cut across the x-axis, they are said to be the solutions of the problem. So which means this is a root 1 and this is root 2. So which means this is root 1 and this is root 2. No wonder I understand that whenever I'll be solving the quadratic actually equation using the graph method, we'll have the solutions based from where the graph is cutting across actually x-axis. You understand this? And the point in which the graph is turning is said to be a turning point. So this is said to be a turning point. So that is said to be a turning point. So that's a turning point. So that is said to be a turning point. But now, since the graph has concave upwards, it means the turning point is said to be minimum point. So turning point is said to be a minimum point. Again, since the graph has actually concave upwards, it means the turning point is said to be the minimum point. So that's the minimum point. And what are the coordinates at the turning point? The coordinates consist with, now have them as this. So which means the coordinates will be having as, now should be this case. And get it right in this way. So the turning point consists with two coordinates given as this is x and this is y, which means we'll have it as x comma y. Should be, these are the coordinates at the turning point. So mind you, I've said that this is the minimum point because the graph has concave upwards. So now, what has really constituted to have this one as the minimum point? Why is this one said to be a minimum point? So at the minimum point, a y is said to be a minimum value. So this one is said to be a minimum point because the y is said to be the minimum value there. So in that case, the y should be which means the y value at the turning point is said to be the minimum value. Said to be a minimum value. So okay, so take it okay there. So again, now since the value of a is positive, the graph has concaved upwards, and the turning point is said to be the minimum point, and the y value at the turning point is said to be the minimum value, and the turning point consists with the two coordinates given as x, y. Have that in mind. And there's also something I should have to express here about the equation of a symmetry, or the line of symmetry. So what is that? So if we say a line of symmetry, it is the line, if we say the line of symmetry, it is the line that happens to cut across the object into two equal parts. That's the line of symmetry. So in the sense that, in this case, actually a quadratic graph can be cut into two equal parts, where you can have it as this. So this is the line of symmetry, where the graph can be cut into two equal parts, this part as well as this part. And you can see that the line of symmetry is passing across the x-axis, value, and that x-axis value, so should be this. You can see that the line of symmetry is passing through the actual x-axis, at which the value actually you can see that the line of symmetry is passing through the x-axis, of which the value along that x-axis, it is the x-coordinate at the turning point. So hence the line of symmetry, or the equation of a line of symmetry, is the same as the x-coordinate at the turning point. So have it in mind. Now, what if the graph is to concave upwards? Let's say this is the case. So it should be concave downwards, not upwards. So now we'll have it as this case. So let's say the graph is going off like this. So in this case, it means the value of a, it is given as the negative. So hence the graph is to concave downwards, if that's the case. And as true more, this is said to be this is the turning point. So now, since the graph has concave downwards, it means it is no longer minimum point, but it is maximum point. So take note of that. And as true more, the turning point consists with the actual x value as well as the y value. And the y value at the turning point is said to be the maximum value. So bear that in mind. And what is the equation of line of symmetry? So it is going over like this. So which means equation of a line of symmetry is the same as the x-coordinate at the turning point, as I have already specified that one. So take note of that. And these will be the solutions of the actual function upon having brought it in that way. So bear that in mind. So how can you be able to have the following operations if this is the case? Now, without drawing the graphs, A, determine the concavity of the graph. Concavity of a graph. And B, actually we should have to determine the equation of axis of symmetry. So symmetry. mind you, without coming up with a graph. And C, we should have to determine the coordinates at the turning point. Coordinates at the turning point. And G, we should have to determine the maximum value or minimum value based on the problem. So let's start. Let's say we have a function f of x is equal, let's say, x squared and plus 4x, and that should be plus 2. So what is the concavity of this graph, the graph of this function? So now, what is the value of a? We have it as a 1, and b is given as 4, and the c is given as actually 2. So since the a is positive, it means the graph will have to concave upwards. So since the value of a is positive, then the graph will have to concave, then there should be actually upwards. So take note of that. And how should we be able to have the equation of a line of symmetry if this is the case? How should we be able to have that out? So now, the first thing we should have to calculate, mind you, equation of a line of symmetry, it is the same as the x coordinate at the turning point. That is x coordinate at the turning point. So what is the equation, what is the formula that can help us to have the x coordinate at the turning point? We have it as negative b over 2a. So this is the formula that will help us to have the x coordinate at the turning point. So what is the b? We'll have it as if we'll have negative 4 over 2 times 1. That will be given as negative 2. So which means at the turning point, we have the x coordinate given as a negative 2. So which means the equation of line of symmetry is given as x is equal to negative 2. We are done there. And the other part of the question says that we should have to calculate the coordinates at the turning point. So since we already obtained the actually x coordinate at the turning point, we just have to substitute the value into the original function to have the y value. So now which means we'll have it as a y is equal, now mind you, f of x, it is the same as y, so have negative 2 to the power 2 plus 4, negative 2 into plus 2. We'll have it as a 4 minus 8 and plus 2. That is the given as a 6 minus 8, which is the same as negative 2. So which means the turning point consists with the coordinates given as negative 2, negative 2. So take note of that. Now, what is the maximum or the minimum value at the turning point? So now, since the value of a is positive and the graph has concave upwards, it means we're going to have the minimum value. So therefore, a minimum value is given as y is equal to negative 2. So mind you, the minimum value, it is the actually a y value at the turning point. So bear that in mind. Now what if we have this case? Let's say we have a function, a y is equal to, and that should be now that of x squared and plus 4x and minus that of 4. So what is the concavity of the graph? So now the graph will have to concave upwards, because now we have a being given as a 1, b is given as 4, and the c is given as negative 4. now the graph have to concave upwards because the value of a is positive. That's the first answer. And since the graph has been concave upwards, it means that we're going to have the maximum. Actually, we are going to have the minimum value. That will be given as the y-coordinate at the turning point. So what is the equation of line of symmetry? We'll have it as the x-coordinate at the turning point. That is given as negative b over 2a. This is the formula. That is given as negative 4 over 2 times 1. That will be given as the negative 2. So now, this is the actually a line of symmetry is given as x is equal to negative 2. We are done there. Now how about the coordinates at the turning point? We'll have to substitute x into the original function. That will give us now a y is equal to negative 2 to the power 2 minus 4, 2 like that, minus 4. And that will be given us and 4 minus 8 minus 4. That will be given as the negative 8. So which means that the turning point will have negative 2, negative 8 in that case. So what is the actually a minimum or the maximum value? So now since the graph has concave upwards, it means we'll have the minimum value being given as y is equal to negative 8. So take note of that. So that is the minimum value we should have to know. And what if we have this case as well? We should see how best we should have to understand that one up to. Let's say have y is equal to, and that should be negative x squared, and plus 4x minus 7. So now we'll have the value of a being given as negative 1, and b is given as a 4, and the c is given negative 7. Of which we do not have much use with actually c, but just have to denote it. So now since the value of a is negative, it means the graph have to concave downwards, and we're going to have the maximum value in that way. So what is the actually equation of line of symmetry? That is the x-coordinate at the turning point. We'll have it as negative b over 2a. So what is the b? We'll have negative 4 and the 2 times negative 1. That will be given us now a positive 2. So which means the line of symmetry is given as x is equal to negative, actually is equal to positive 2. We are done there. The next we should have to deduce the coordinates at the turning point. So since we already have the x value, we will just have to substitute the original function. We'll have y being given as negative 2 to the power 2 and plus 4 times 2 minus 7. Now have it as negative 4 plus 8 minus 7 like that. Now have it as negative 3. So which means at the turning point we'll have 2, negative 3. So now since the graph has concave downwards, it means the maximum value is given as the negative 3. So that's the maximum value. And I think of this as well, and I appreciate. Let's say we have a function that which is given as, let's say y is equal to 1 should be x minus 3. Let's say x minus 3, let's say the power 2, and plus 4 as well. So is the graph concave downwards or upwards? So now first things you have to expand the expression. Now have it as y is equal to x minus 3 times x minus 3 and plus 4, of which y is given as x squared and minus 3x and plus 9 plus 4, of which you have y is equal to x squared minus 6x and plus 13. So try to determine everything we have discussed here in that one. And also try this at your own time. Also, let's say we have y is equal to x squared, let's say minus 4x plus 7. Also try that one as well at your own time. And also think about this one as well. let's say y is equal to, let's say x minus half to the power 2, and that should be that in the minus 2. Also try that one as well at your own time. And also try this one, y is equal to negative x squared minus 6x. So try to have that one as well at your own time. And also think about this one as well, just to have it as, let's say y is equal to x squared and minus x minus 1. And also have that one now, let's say have y is equal to x squared plus 5x minus 6. Also try to have that one as well. So that's how you have to understand about the line of symmetry. Actually, the coordinates at the turning point and the maximum or minimum value without having the actual graph. But just have to theoretically analyze the concept. You can be able to have all those things. So thank you.